In this video, we shall discuss about the next topic, that is from the chapter 1. It is about the microprocessor specifications. So before going into the specifications of the microprocessor, we shall discuss about what is a microprocessor and what are its functions. So we learned about the central processing unit in the previous videos. So the central processing unit is the brain of the computer, and it is responsible for performing all the calculations and making decisions based on the user input. So that is the function of the central processing unit. So it is the main part of the computer which performs all the calculations and makes decisions based on the user input and the operating systems. The same central processing unit, when it is implemented using a tiny chip that fits in your palm, then we call it as a microprocessor. So microprocessor is nothing but it is a small sized electronic component inside the computer that carries out the various calculations and data processing and arithmetic and logical operations. So that is microprocessor. So it is a small sized electronic component inside the computer which carries out all the arithmetic and logical operations and other data processing. So a central processing unit which is implemented on a single chip, we call it as a microprocessor. So we shall now see in detail about the evolution of the central processing unit. How the central processing unit has evolved. Initially how it was built and now how it has developed. So we shall see the evolution of the central processing unit. So initially the central processing unit, it was big and bulky. We shall see each one in detail in the next slides. I'll just give you the introduction. So initially the central processing unit was big and bulky, and later on with the advancement in the technologies, it was implemented in integrated chips. Okay, so and also the power and the speed of the central processing unit is now improved or increased a lot with the improvement or advancements in the technologies, and multi-core revolution has taken place in the CPU, and now it has become more affordable and more accessible when compared to the earlier CPUs. So how this CPU has evolved from the earlier CPUs, what are the advancements now grown due to the advancements in the technology. We shall see that in the next slide. So from room sized machines to tiny chips. So initially earlier days the CPU was very big. So it occupied a large amount of space. It needed a big room sized machines. So the CPUs were room sized big machines and it occupied large amount of space. But with the growth of technology, the CPU size has reduced, and now it is possible to place a single CPU on a single microchip. Okay, we can place a CPU on a single microchip. So the CPUs were massive and it filled the entire rooms, and since it was very big, it consumed a lot of power. But with advancements in electronics, so now more transistors, resistors, diodes have been developed. So these big machines, now it is replaced or changed into tiny efficient microprocessors. Microprocessors are nothing but the central processing unit implemented in a single chip. So that since the size of this machine is reduced, it is very smaller, but it is faster and it is more affordable. So earlier computers, CPUs were very big and bulky, but with the advancement in electronics, it is made into an efficient, a small component or a device which is very faster, smaller and more affordable. And next is, nowadays it is coming in integrated chips. So these days the microprocessor is built over an integrated circuit. So integrated circuit is nothing but it contains millions of tiny components like transistors, resistors and diodes. So that is all packed into a single chip. So that is called as the integrated chips. So the central processing unit is built using millions of tiny components like transistors, resistors and diodes. So we call it as an integrated chips. So these microprocessors, they have evolved over time. Initially it was big and bulky, and then all the tiny devices were replaced by the tiny components in a single chip. And so just because it has evolved over time, the processing capability has increased a lot, but the size of the processor has decreased, and so the cost of the processor is also reduced. So since the size is reduced, the speed is increased. So earlier CPUs, it operated at the speed in kilohertz, but nowadays the processors run at gigahertz, that is billions of cycles per second. Okay, so it is able to process millions or billions of instructions per millisecond. So that is how it is faster now. And next is, if the speed is very fast, it can perform complex tasks instantly. So that is the advantage of the integrated chips. And also processors are capable of processing millions of instructions per millisecond. So that is how the speed and power of the microprocessors have evolved. So currently the processors are able to process millions of instructions per milliseconds. And next is the multi-core. So initially the CPU had only one core, meaning they could handle only one task at a time. Now multi-core processors means there are many cores. That is, dual core means there are two cores, quad core means four core processors are there. So when the processors are multi-core processors, it allows us to do multitasking efficiently. So we can complete multiple tasks at a time. So that is multi-core revolution. So the number of tasks which is executed at a time is increased. So we can do multiple tasks in a given time. So that is the evolution of the CPU. So it was big and bulky, and then it was integrated in a single chip. So the speed and the power of the processors increased, and so we can execute multiple instructions within millions of instructions in milliseconds. And next, since there are multi-core processors evolved, we can do multiple tasks at a time. So this is the evolution of the CPU. And next is the accessibility and affordability. So nowadays the processors have become very cheaper and it is more powerful. Because the size of the CPU is reduced and it is almost implemented in a small chip, it consumes less power. So all the components needed to build a big machine is not necessary now. So it has become very cheaper, but it is more powerful. The speed and the power of these processors are more powerful. So now today the processors are found not only in computers but also in smartphones, washing machines, cars and even toys. So almost in all the electronic products we can see we are using the microprocessors nowadays. And this is about the generations of the microprocessor. So in the first generation, the type of the chip which was used was LSI, which is large scale integrated circuit, which is this LSI, VLSI, it all specifies about the number of transistors used in the integrated chip. So integrated chip is nothing but the tiny component of the processors like transistors, diodes, all are placed inside a single chip. So that is the integrated chip. And if there are, based on the number of the transistors, we classify the chip type as large scale integrated, very large scale integrated, and super large scale integrated. That is the fifth generation computers. So the first generation, second generation are the large scale integrated, and the third generation and the fourth generation are very large scale integrated. So the number of transistors used in the VLSI will be around hundreds of thousands of millions of transistors used in the processors. And if we see about the word size, in the first generation the word size was 4-bit or 8-bit. In the second generation it was 8 bits, and in the third generation it is 16 bits, and in the fourth generation it is 32 bits. And if we see the memory size, the first generation is 1 kilobyte, second generation is 1 megabyte, third generation is 16 megabyte, and the fourth generation is 4 gigabytes. And if you see the core, the first generation there was only a single core processor, second generation also single core processors, and in the fifth generation now it is multi-core processor. And the examples of some of the processors are Intel 8080, 8085, 86, 80386, and in the fifth generation now we have Pentium processors and Xenon processors. And if you see the clock speed, it was initially in the first generation it was up to kilohertz, and in the second generation and third generation it was up to megahertz, and in the fifth generation it is now up to gigahertz speed. So this is about the generation of the microprocessors. And now next we shall see about the microprocessor specifications. So far we discussed about the what is a microprocessor and the evolution of the microprocessor and the generation of the microprocessors. So 3 topics we have discussed, and this is the next one, microprocessor specifications. So the microprocessors are classified on the basis of different features like the chip type. Chip type means whether it is a large scale integrated circuit or very large scale integrated circuit based on the number of transistors used. And we use the word size, memory size, clock speed, and the core. It is classified. Based on these features, a microprocessor is classified. So what is the word size? Word size is nothing but it is the maximum number of bits that a processor can process at a time. So earlier computer can process up to a word size of 8 bits only. So only up to 8 bits the processor can process the data. But now at present the modern processors, they have minimum word size of 16 bits and the maximum word size is 64 bits. So the size of the word size has tremendously increased. So the amount of data processed is also increased. So what is the advantage of increasing the word size? So the large word size, it allows the processor to handle more data, and so we can perform more complex operations per cycle. So that is the advantage of having increased word size. It allows the processor to handle more data. So the number of bits the processor can handle in one operation is called as the word size. A clock speed. What is the clock speed? Computers have internal clock that generates signals at regular intervals of time. So the clock speed indicates the speed at which the computer can execute the instructions. So that is called as the clock speed. So earlier the computer was very slow, and so it can execute the instructions only in hertz or kilohertz. But in advancement in technology and the chip design, now the speed has increased up to gigahertz. That is, it can execute billions of instructions per second. Okay, and so next is the core. So core is the fundamental processing unit of the CPU. Earlier processors had only one computation unit. So it was capable of performing only one task at a time. But now with the advent of multi-core processor, there are many processors, so it is possible for the computer to execute multiple tasks simultaneously. So since it is able to execute multiple tasks, the system performance is also increases. Okay, so now the multi-core processor, there are 2 core, 4 core and 8 cores. So 2 core is called as a dual core, 4 core is called as a quad core and 8 core is called as a octa core processor. So the main advantage of having multi-core processor is the computer is able to execute multiple tasks simultaneously so that the system performance will be increased. Thank you for watching the video.